Okay, on all these types of problems, all we are trying to do is to plug things in, okay? If you've taken chemistry, you have already done stuff with half-life, okay? I am giving you a formula, so you do not need to take an element and then carry it out however many times you need to, like you did in chemistry, okay? We are giving you formulas, you need to use them, okay? I will always give you the formula I want you to use. I will always tell you what the things mean, so you do not have to memorize any formulas either. Okay, so for like number 1, when a plant or animal dies, it stops acquiring carbon-14 from the atmosphere. Carbon-14 decays over time with a half-life of 5,730 years. How much of a 10 milligram sample will remain after 22,920 years? So, what are the important parts of this? Do I need to know that it's 14? No, the 14 doesn't matter there, okay? We need to know the half-life, 10 milligrams, and the total amount of years. Then it's just about plugging things into the right place. Okay, so we've been given this formula. So N is the amount left. So that's what we're solving for. This is N sub O. That's how you say that. Okay, it's like a subscript. So don't say no. It's N sub O. That's how you say that. Okay, so N sub O is the initial amount. Remember, initial amount means what you start with. So how much did we start with in this problem? 10 milligrams. So 10 milligrams multiplied by 1/2 to the T. T stands for time in years. What's the total time in years? 22,920. Divided by H is the half-life. What is the half-life? 5730. Now, for this type of problem, yes, you could use a calculator here. If you simplify, we do 10 times 1/2. If you use your calculator, that is to the 4th power. That is pretty much the end of where you need to use a calculator on this problem. Okay, from here, what do I do next? Should I multiply 10 times 1/2, or should I do the exponent?
Exponent comes first.
Exponents come first, right? So 10 times, what is 1/2 to the 4th power? Not 1/2 times 4. 1/2 to the 4th power is 1/16. Now, if you multiply, I do not want you to use your calculator for this. Okay, it's a little bit too complicated. Just multiply across the top and the bottom. So 10/16, and that reduces to what? 5/8. So 5/8 grams. 5/8 of a gram is left behind. That's it. That's your answer. So all of these types of problems are just plugging things in the right place and solving. Okay, they're just exponential equations, and those are all doable.
If you don't do it this way, you're gonna mark it wrong.
If you did it what way?
Like if you don't do it this way, if you do it like a different way.
What other way could you do it?
Like a more complicated way. I don't know. No.
I want you to show work. If you want credit, you need to show work.
Well,
yes.
yeah, but like.
How do you know which one goes on top?
Okay, because it said T was the time in years, H was the half-life. It gives you the key, so you have to just put the things in the right place. Okay, let's try another one. One certain element decays over time with a half-life of 800 years. Should say years. Use the formula to determine how many grams will remain after 3,200 years if 500 grams were present originally. So A is the amount present originally, so Y equals, what's your amount? How much did we start with? 500 multiplied by 1/2 to the T over H. What's T here? 3,200 over, what's its half-life? 800. Now, you do not need to use a calculator for this. The zeros cancel. What's 32 over 8? 4. Okay, so 500 multiplied by 1/2 to the 4th power. What is 1/2 to the 4th power?
1/16.
1/16. If you multiply those together, you should get 31.25 grams. Okay, that is something that you could use a calculator for, or you could do with long division. If you write 31.25, that is equivalent to 31 1/4. So either way you write it is fine. Okay, either way is going to be fine with me. Anybody have questions so far? Okay, not too bad. As long as you plug things into the right place, it shouldn't be too bad. Now, if for some reason you messed up and lost the decimal place here and you got 3,125, would that make any sense? No, because you started with 500 and we know that this is decaying. So use common sense and think about it when you get an answer. Does this make sense? Okay, especially because we're dealing with a lot of decimals and fractions. For number 3, the radioactive gas radon has a half-life of approximately 3.5 days. About how much of a 300-gram sample will remain after 1 week? Okay, so Y equals the amount that's left behind. What was your original amount? What did I start with? 300. Original amount. Days is not an amount. Times 1/2 to the T is time in days that has passed. So how many days have gone by?
1 week. 7.
1 week, so 7 days over half-life is what?
3.5.
3.5, but it makes a little bit more sense to put 3.5. Okay, so you don't have that weird double-decker kind of fraction. So 300 times 1/2 to the, what's 7 divided by 3.5? 2. Just 2. 300 multiplied by what's 1/2 squared? 1/4. And then what is 1/4 of 300? Okay. 300 divided by 2 is 150. Divided by 2 again is 75. Okay, 75 grams would be remaining. You guys can do that in your head. You should be able to do that in your head. This it does involve thinking. Okay, for number 4, deconium-25 decays using the formula A equals I times 2 to the negative T over H. Okay, now this is decaying, so think about it. You should get a less amount. Okay, we should be losing here. Half-life is 2 years. Find out how much of a 240-gram sample remains after 4 years. So the amount left behind is your initial amount. So how much did I start with?
25.
240. The 25 has nothing to do with this problem. It's just in the name. So 240 times 2 to the negative, what's your total amount of time?
Wait,
Total amount of time is 4. Its half-life is 2. So these aren't actually very difficult problems if you put things in the right place. So you have to read them so you make sure that you put them in correctly. So if you work this out, we get 240 times 2 to the negative 2. What is 2 to the negative 2? Okay, remember, make it a fraction, bury it, so over 1 over 2 squared. What is 2 squared? 4, so 240 times 1/4 gives us what? 60 grams. Yes.
I got that, but I didn't do the negative T.
What'd you do?
I just did positive T.
Well, that would be 240 times 2 to the 4th, which is times 16. That would give you wrong. That would mess you up. They give you a wrong answer. You have to do a negative fraction so that you get 1 over. So you made a mistake somewhere there. Okay, the next one. On number 5. Begonium decays using the formula A equals I times 2 to the negative T over H. I is initial amount, T is time in hours, H is half-life. Okay, so half-life is 4 hours. How much of a 24-gram sample will remain after 6 hours? So let's plug things in here. So the amount left behind is equal to, what's the initial amount? 24 grams multiplied by 2 to the, what's your negative T? Negative 6 over 4. When we reduce this, we get 24 times 2 to the negative 3/2. Is there an easier way to write negative 3/2? 1.5. So the negative 1.5. Do you know how to find what is 2 to the negative 1.5?
Nope.
Not so much, right?
Nope.
Now, but I can approximate. Could you do 24 times 2 to the negative 1?
Yeah.
Yes. Could you do 24 times 2 to the negative 2?
Yeah.
Is 1.5 in between 1 and 2?
Yeah.
So you can solve these, and if you do, you get 24 times, what's 2 to the negative 1?
I don't know.
1/2, which multiplies to be 12. Multiply this together, 24 times, what's 2 to the negative 2? 1/4. What's 24 times 1/4? 6. So would you agree that the amount left behind should be between 12 and 6?
9.
Okay, not necessarily 9. It doesn't work exactly like this.
8.5.
But look at your multiple choice. Only one of them works there, right? So sometimes we actually have to approximate. Okay, so you might have to approximate in between two whole numbers that you can simplify.
What if you have to approximate and there's like 2?
The only time you're going to have to approximate, there's only going to be one logical answer. You wouldn't have like 2 in that same range. So if you have problems like that, you may need to approximate, and that is fine. Okay, let's try number 6. A culture of yeast doubles in size every 20 minutes. The size of the culture is now 80. Find its size in 1 hour. Remember to convert 1 hour to minutes. So, a culture, it's like a sample. So a sample of bacteria. Okay, I counted the bacteria somehow, and there's 80 of them now. So find its size in 1 hour. So y equals, what is your initial population? 80, because that's how much you have now. So 80 multiplied by 2 to the, what's your total time elapsed? 60 over its half-life is 20. So work this out, 80 multiplied by 2 to the third power. What is 2 to the third?
8.
And 80 times 8 gives you 640. So in 1 hour, we'd have 640 bacteria. Question? Okay, 2 more. How'd I get what? Number 7, the growth of a town is given by the formula y equals y sub o times 2 to the t. If there are 4,000 people after 4 years, find the initial population. So when we're plugging things in, where does the 4,000 go? Is that y or y sub o?
Y.
That is y. So 4,000 in 4 years from now equals, do we know how many there are now? No, that's what we're solving. So y sub o multiplied by 2 to the how much time has passed? 4. So I'd give you 4,000 equals y sub o times what's 2 to the 4th power? 16.
Yeah.
Then divide both sides. 4,000 divided by 16 gives you what? 250. So 250 is the initial population.
Wait, what did you do to get 250?
I divided both sides by 16.
Oh, okay.
Okay, last one. The number of people with the flu virus is growing exponentially with time as shown in the table below. This is true, okay? Like if you've ever heard like the Centers for Disease Control, the CDC, they're trying to predict, like how much vaccine needs to be made. They might need to use an exponential equation, okay? Like say I was sick today, but I started feeling really bad yesterday, but I was contagious right now.
Okay.
I would infect everybody that I come in contact with. So say I came in contact with 300 people. Totally legitimate because I teach about 200 people and I don't know, I see a bunch of other people during the day. Okay? How do I figure out which equation fits? By tomorrow, I've been sick for 1 day. Now 600 people have it because all of you have exposed your families and your friends. So things grow exponentially. This is a real world situation.